Let's take a look at a concrete example from Mario in TypeScript. So this is the hit code that handles what happens when two figures from Mario run into one another. Now testing is a great opportunity to go back and revisit the specification for the system. So let's take a look at that with respect to this function. So what do we want this code to do when we execute it in practice? First, if Mario lands on an enemy, the enemy is the one who should take the damage. Next, if Mario runs into an enemy or an enemy runs into Mario, Mario should take the damage. Finally, if two enemies run into each other, nothing should happen at all. So in this function, we have one figure hitting another figure, who is the opponent. The boolean that is returned signifies whether or not a figure gets killed from the hit, but doesn't specify which figure actually gets killed in practice. We've gone ahead and broken down this code into parts. Note, the parts in this diagram are not exactly blocks, but are instead logical units. If this were a block diagram, the if statement in block B would technically be a part of A, but we have separated them to clarify the program flow we are talking about. So the first two lines of the function are denoted as block A. The first if statement encountered is block B. The next if statement is block C. The then and else statements for block C are block D and E. The final if statement is block F, and its then and else statements are block G and H, respectively. Let's start by stepping through this example in terms of line coverage. With line coverage, we want to design a set of test cases that will execute every single line of the program. First, let's look at a truth table for this example. The rows of the truth table correspond to our program parts from A to H. The columns will correspond to our test cases. In each cell, we'll put a check mark if the test executes that line, or an X if the test does not execute that line. You note that blocks D and E both contain two lines. We've lumped these together because executing the first statement always means the second statement will be executed, so this really just simplifies the discussion. Let's design our first test case. Test 1 is going to be Mario jumping on an enemy, and the enemy being killed. So the pseudocode for this test would look something like this. Turtle.hit, taking a parameter new Mario with direction down. Let's take a look at which lines of the function are executed by this test. So we enter at block A and evaluate the first if statement, which looks at whether or not the parameter is a Mario. Since it is, we move on to block C, which evaluates whether or not Mario is heading down. Since Mario is heading down, we go into block D, where we see that the turtle is hurt by Mario. We also set being hurt to this, so the turtle is the element that's being hurt. We move into block F then, and here we know that being hurt is not null, right, because it's the turtle, and being hurt.dead we assume to be true, right? So we don't test whether or not being hurt.dead is being set correctly. This is handled by whatever tests evaluate the hurt by code, so we'll just assume that they're correct. But here, we assume that the turtle is dead, and we move into block G, the final then statement. Looking at the truth table, we can see that this test executes all lines of the program except for blocks E and H. Right, so this is a pretty good test case, but we're going to need to design another test to further execute the rest of the system. So to execute lines E and H, what we need to do is we need to design a new test where Mario runs into an enemy, but Mario does not actually die. So this test case is going to look like this in terms of pseudocode. Turtle.hit new Mario, who's moving right, and who's in state big, right? Because if Mario's big, he will survive the encounter. So once again, we flow into the program at block A, and evaluate the first if statement in block B, and we find that again, the parameter is a Mario, so we move to block C. Now at this time in this if statement, Mario isn't heading down, but is instead heading right. So instead of taking block D, the then statement, we instead execute block E, the else statement. In this case, Mario is the one who takes the damage from the turtle, and being hurt gets set to Mario himself. Now when we flow into the if statement in block F, something different happens. So here, being hurt is not null once again, but being hurt.dead is not true, right? Because Mario was in state big, so he survives, and we flow into block H, executing the else statement. Going back to the truth table, we can now see that these two tests together cover all of the lines of code within this function, which is fantastic. We've managed to achieve 100% line coverage. While our test suite now has 100% line coverage, if we wanted to have 100% statement coverage, we'd have to look at lines that have multiple statements. Line F is the only such statement in this function. So here we have being hurt does not equal to null, and being hurt.dead is equal to true. So to achieve 100% statement coverage, we need to make sure that we execute both of these options. And it turns out our two tests do this, so we have both 100% line coverage and 100% statement coverage.